In this video, we're going to do some conditional probability. So here's the problem. Are boys more likely than girls to wear a backpack to school? To find out, I surveyed 120 high school students. 34 boys said they wear a backpack to school, and 26 girls said they did not. In total, I found 58 students who said they like to wear a backpack to school. And then we have 2 questions that are conditional probability. Before I answer those questions, I need to somehow organize my data. So I'm going to make a two-way table because that is my favorite type of display. So on this side, we are talking about some boys and some girls. Okay? And then over here, this is, are they wearing a backpack? So backpack, our options are yes or no. And then, just like always, I want to leave myself some space for totals. Okay, so I will use my blue pen to fill in things that we know straight from the problem. So let's go back to the beginning. I surveyed 120 high school students, so that must be the total people. 34 boys said they wear a backpack to school. So boys, backpack, yes, 34. 26 girls said they do not. Girls, no, 26. In total, I found 58 students who said they like to wear a backpack to school. So nothing about girls or boys, just 58 for total backpacks. Okay, let me switch colors for you. Now we are just going to go through and fill in these numbers by adding. So this first column right here, I know it has to add to 58, so this must be a 24. Okay, so now I can add straight across, 24 and 26. That is 50. In my total column, I can make this one a 70, which means that is a 36, and this is a 62. All right, we're ready for questions. Part A. Given that the student was a girl, what is the probability that she does not wear a backpack? Okay, so I'm going to write a probability statement. Given that the student was a girl, what's the probability she does not wear a backpack? Okay, conditional statements work like this. What this means is the probability that A happens given that B already happened. So B, this is the thing you know for sure. So when we look back at our problem, what is the part we know for sure? It's this. The person was a girl. So that's going to go after. So probability of no backpack, given that it's a girl. So the easiest way, I think, to look at these is that the part I know for sure limits my population. So I know that this person has to be a girl, which means I'm looking at these 50 people. She's one of those. If it's a girl, it has to be one of those 50. So this has to be out of 50. Now the question is, of those 50 people, who had no backpack? That's those 26. So tiny bit over half. We have 0.52. Okay, let's do that one more time for the second one. If you know the student's a boy, what's the probability that he has a backpack on? Okay, so look back up here. Think about what the thing that you know for sure is. This one says, if you know the student is a boy, okay, so that's the part I know for sure. So again, that goes at the end. What is the probability that he has a backpack? Yes, backpack, given that it's a boy. Okay, same thing. So because I know this person is a boy, I care only about these 70 people. So those 70 boys are what my population is limited to. So I know it has to be one of the boys of those 70 people who has a backpack. 34 of them. And this is 0.4857. There you go, about 49%.